My name's Sebastian Major, and I am the host of the Our Fake History podcast.
I'm Rebecca Larson with the Tudors Dynasty podcast.
This is Greta Harden.
My name is Benjamin Jacobs.
I'm Anton.
And I'm Rick.
I'm David Montgomery.
I'm Bree.
My name is Roberto Toro.
I'm Jamie.
And I'm Rob. We will be speaking at Intelligent Speech.
I am looking forward to speaking at Intelligent Speech 2023.
I will be speaking at Intelligent Speech Online this year.
Mark your calendars for this November 4th. Intelligent Speech, the online conference for history fans by history podcasters.
It's a 3-ring circus of fascinating content with around 24 hours of live presentations.
This year is all about contingencies.
Times when history meets the unexpected.
The topic of my keynote address is no contingencies.
The Tudors and their contingency plans.
So go to intelligentspeechonline.com to get your tickets.
We'll see everybody on November 4th.
To start our long stroll through the living history resources that the National Park Service has to offer, I'm starting up in the top corner, the northest, eastest state in the Union. Formerly part of the Massachusetts colony, the state of Maine has played an important role in the growth of the country, in fish, in wood, and as home to some of the earliest permanent European colonists in North America. I'm talking about the Acadians, who were some of the earliest French colonists in parts of Canada that's now New Brunswick. They settled largely as a fur colony and had an unusually cooperative relationship with the First Nations people in the area, particularly the Mi'kmaq and other Wabanaki tribes. When the British took over this area from France, about 12,000 people from this area that had been called Acadia were unceremoniously rounded up and deported between 1755 and 1764. Some ended up in Louisiana and became the Cajuns that we get to meet this season, but others were able to canoe up the St. Johns River into Maine and settle there. Their name, the Acadians, also graces Maine's more famous Acadia National Park near Bar Harbor. But up in Madawaska, Maine, you can visit Acadian Landing, the Tante Blanche Museum, and other sites in the Village Acadien and the nearby gem of a 19th century wooden Catholic church preserved as the Musée Culturel de Montcarmel. This often forgotten event, when the British unceremoniously dumped a bunch of French from Canada into those soon-to-be annoying colonies, and what became of them as they set down new roots, can be experienced up in this remote and stunningly beautiful corner of the former colonies and now the state of Maine. So if you're looking for a literally cool summer road trip, the Acadian Landing would fit the bill and give you a peek into a corner of American history that rarely makes history's Hot 100. Episode 92, an explainer of the iron technology available in baby America and how it got that way. Hello, and welcome to the History of American Food. This week, I'll be looking at how the 18th century iron industry that had originally focused on supplying the British Empire made a rapid shift to only supplying the home needs. How did the furnaces supply iron to forges? How did furnaces work at all? But first, I'm also doing a deep history on how iron manufacture got to where it was as the century changed over. So pull up to your place at the table and let's dig in. The first thing you need to know is that part of the British downfall in the War for Independence was their desire to fight the French and the Spanish better in the Caribbean. They also wanted to get a leg up on the expanding whaling industry. For those reasons and a few others, they transferred a lot of technical knowledge about how to make iron stuff for war and the shipping industry to the North American colonies. Much to the chagrin of the British, many of the guys with the most innovative ideas went over the ocean where they could test out all their new cool ideas. The colonies was where there was a lot of elbow room, cheaper fuel, and no stodgy old iron masters playing for a team. It's always been done this way. Innovation breaks our long, honorable traditions of etc., etc., etc. It's true that at this period, the best cannon were being made by the old factories back in Europe, England, but also France and Prussia, that is, old Germany, because they were fighting lots of wars. Ever so many wars with each other, but notably internally with themselves. Cannon were big, slow, expensive jobs after all, so innovation was always going to be harder. But better guns, especially rifles and plows for faster farming to feed the troops, that's where the new Americans were really pulling ahead. Oh yeah, and these new men, alas yes, at this point nearly all iron workers were men. We'll talk about support staff in a bit. But all these new men were also coming up with more efficient fabrication methods, both in turning the raw iron into workable steels and for making items faster and of more dependable quality. But before we can get into how things were being made better and how the industry was changing and then about to change again, it's time for me to do some pretty serious history of iron manufacture. Way back in season 1, at the very beginning in the first 3 episodes, I talked a little about how iron making the world over had been more or less on an equal footing in Africa, in Europe, in India, all the way through about the 13th century CE. There were pockets that got ahead, had better raw materials, or adopted novel techniques, especially in China, but the big split came when some areas adopted water power to help with refinement, which allowed those iron cultures to start turning out larger quantities of iron products. If you can get water to drive your hammers, you literally have to grow less food per kilo of iron produced. And in the, quote, you have to work for every calorie, unquote, food economics of the time, this harnessing of power you didn't have to directly feed your food to made an enormous difference. There will also be several technological advances in all of these regions that will cause different areas to be ironclad powers at different times and in different ways. But this is the American Food Podcast, so I'm grabbing hold of the narrative and bringing it back home. The way iron manufacture in North America started was by digging up what is called bog iron. Now stay with me for a minute. I'm about to go far, far into the past here. Way back before there was an Earth, or planets at all. Giant stars were out there in the young cosmos, smushing hydrogens together to make heliums, then dying and exploding, and then they made new stars, which then smooshed together the hydrogens and the heliums in their hearts to make bigger and bigger elements. Regular stars, most of the ones we see out there now, also keep smooshing smaller elements together until they top out at about element number 26, iron. This is why most of the elements we find out there as planets, asteroids, and other space junk are all in that first few rows, and most of them are really familiar. Hydrogen, helium, carbon, oxygen, nitrogen, sodium and chlorine for salt, calcium for bone, sulfur for gunpowder, phosphorus and potassium for fertilizers, neon for signs, and here in the 21st century, silicon in our computers, lithium for batteries, titanium for aircraft, and because it looks cool. Anyway, the stars die and break apart in more and less dramatic fashions, and that's the source of most of the star stuff that makes up most of the solid stuff we see in the cosmos. Almost everything bigger than iron, element number 26, is made when stars explode dramatically, when they go supernova. Turns out there are lots of different types of supernovae, bigger ones, smaller ones, bright ones, dull ones, and even super duper big ones called hypernova that produce black holes and killing waves of X-rays and stuff. And a quick shout out to one of the OG educational podcasts that's still going strong, Astronomy Cast, for all your further star curiosity. Anyway, these dramatic supernovae, they create all sorts of extreme conditions that allow for the fusion of particles into elements bigger than iron. Some fall apart rapidly and we never ever see them. All that stuff in the actinides and lanthanides, those elements with the weird names that hang out in what is essentially the appendix of the periodic table. But others are stable and comparatively common, and we're familiar with them. Stuff like nickel, silver, gold, platinum, palladium, tin, zinc, lead, mercury. better telescopes and advances in stellar chemistry, astrochemistry. Anyway, more recent scholarship has shown that iron, 26, isn't actually the hard limit. There are some complicating circumstances where some heavier elements are produced in the older massive stars. But like I said, go bother Astronomy Cast's 600 plus episodes with your further questions. So, stars died in different ways, and over time our planet formed out of the rocky space junk, which contain lots of iron, nickel, and silicon, pretty good amounts of carbon, and some other useful elements. 4.5 billion years later, here we are. The earliest iron of all to be used on Earth by people was iron from meteorites, and these are chunks of more or less pure iron with a bit of nickel stirred in. Notably, they're pure metal, that is, not combined with oxygen. After all, outer space is well known for generally lacking oxygen. Now, thanks to some water ice space junk that crashed into the rocky ball that became our home, we also have an enviable amount of water to work with. And that water, when it runs over iron-containing rocks, will dissolve the iron. When the water is exposed to acidic conditions, the iron precipitates out into iron oxides. And such conditions exist when you have slow-moving collections of water with actively rotting vegetation, or what's known in the freshwater biology biz as nutrient cycling. Here in America, we often call such places swamps, but back in England, those areas were known as bogs. They have lots of other names around the world, including bayou, fen, and muskeg. Through processes that seem to include enzymes and or iron-depositing bacteria, yep, those are a thing, iron oxide accretions, or lumps, will accumulate in bogs. And it was this bog iron, chunks dug out of swamps in Virginia and Massachusetts and New York, that was some of the earliest iron extracted from iron ore in North America. Incidentally, by retaining wetlands, this is a way to produce renewable sources of iron ore that can be harvested about every 10 years. Now, the wetlands permits would likely be an impossible headache, but it's something to consider. So, back in the 18th century, as the bog iron deposits were depleted, iron ore-bearing rock was hacked out of the earth. And those iron ore deposits were, of course, found upstream of the areas that had iron-producing bogs. For people that study geology, incidentally one of the earliest scientific disciplines to develop useful systems, once they get a sense of the patterns that rocks have, there's a lot of information that rocks can tell you. And people can follow watercourses, streams and rivers, and extruded piles of rocks, that is, mountains, with a pretty good sense of where to look for certain types of rocks for different purposes. Anyway, so those different iron ores, when heated under the correct circumstances, will detach the oxygen from the iron and allow pools and chunks of elemental iron to be produced. By the 18th century, and specifically here in North America, blast furnace technology was at work. This meant crushed iron ore rocks, combined with wood charcoal and limestone, were placed in preheated furnaces. And all the furnaces in the colonies, and then in early America, were wood charcoal fired furnaces. In fact, up until the late 19th century, almost all firing of iron ore was being done with wood charcoal. It's during the late 19th century that the transition from wood charcoal to coal began happening, and it happened with lots and lots and lots of fights. Iron and oxygen make a very tight bond. I mean, given just about any excuse, the two will get together and make what we recognize as rust. Making that elemental iron, the metal we make stuff out of, is basically made by de-rusting the iron. And if you remember or go back to bonus episode 69.5 when I talk about chemical bonding, you know de-rusting iron is going to take a lot of energy. Now, the charcoal provides the heat energy to do it, and under the correct circumstances, a whole bunch of carbon monoxide, or CO, which gives the detached oxygens from the iron a place to go by turning the COs into CO2, carbon dioxide. The iron ore still contains a bunch of silicates which have to be removed as well. And typically limestone is used as the chemical cleaning agent, which is known as a flux. And that will bond with some or most of the silicates in the iron. This heterogeneous mixture, pure iron blobs intermingled with slag, that is, the calcium silicates created by the limestone, is generally termed pig iron. The term pig comes from much, much, much older metalwork. Two things about metals led to the development of the pig naming scheme. First of all, metals are generally heavy. Aluminum's a bit of an outlier, but as a rule, you don't want chunks of metal to be too big because they're hard to move around and because they'd be too expensive for anyone to afford. Also, when metal cools, you want them to cool evenly. If you've ever put a large container of something in the freezer, getting the center to finally freeze can take forever. And when metal cools at different times across an entire piece, weird structural stuff can happen that makes it uncertain to work with. So for this reason, coming up with a way to divide metal into smallish pieces that are easy to move, easy to sell, and cool evenly was key. However, unlike soup, which is pretty easy to ladle into a series of separate containers, metal is not. Molten metal is hot, terrifyingly hot. Iron melts at around 2800 Fahrenheit or 1500 C, and there's no real easy ladle you can use for that. Instead, the floors of iron furnaces were made of fine sand. That sand was then dug with a channel or trough in the middle, and rectangular shapes were created perpendicular to the main channel to hold the ingots of the crude iron. People thought that the main channel with the ingots of metal pointing off of it looked a bit like a sow nursing piglets, and the name stuck. The practice has been found in China dating back to at least the 3rd century BCE, sometime during the Zhou dynasty, and showed up in Europe sometime around the 12th and 13th century, and may have driven the development of the water hammer technology. The pigs produced usually ranged anywhere from about 3 kilos or 6 pounds all the way up to 50 kilos or around 110 pounds. The size was usually determined by how far the pigs would be moved and what the capabilities and preferences of the forges downstream where the pigs were going to be refined were. Large stone furnaces that turned out pig iron were built in many of the colonies, but Massachusetts, Pennsylvania, and Virginia were the most active iron regions. The Appalachian Mountain Range generally was a source of most of the colonial and early American iron, so really most of the colonies touching that range of mountains had some sort of ironworks at some point. Because the furnaces were large undertakings that typically required large cash investments, decent written records can often be found for them. So along with the cost for the actual materials, stones and mortar, and then ore and charcoal and limestone, it's common to also find receipts for the purchases of and rentals of enslaved people who built many of those furnaces. And later on, they would run them as well. Iron furnace work is physically demanding, but also required a large amount of judgment and skill. So not all the furnace builders would work for or often do the work of the iron masters. Many of the enslaved people would move from the furnace building to mining ore and burning the charcoal to run them, which means the early American iron industry was built on the labor of enslaved men and enslaved women who cooked for them. And then these men and women often also worked agricultural jobs. They cut trees and burned charcoal in addition to their iron worker and food-making jobs. As the colonies sorted out their policies on enslaving humans, a split would form in innovation on the iron front. But that will really develop after this time period, so I'll save that for the next series. In the early colonial years, the British prohibited any further refinement of iron past the initial pig stage in the colonies. The crude pig iron that still contained the slag all had to be shipped to England, where iron workers there would pound the slag out with water-driven hammers in forges. The resulting bar iron would be in one of several useful forms. But the ever-dwindling supply of local wood for charcoal and the expense of importing charcoal to make up for these short local supplies, along with the annoyance of having to ship the resulting bar iron back to Boston shipyards in order to repair warships and build new ones to take part in the sugar, slave, and whale trades, inspired London to decide that iron could be refined in the colonies, which meant by the middle of the 18th century, the colonies had built up the forges where the slag was pounded out of the pig iron and made into the iron that could be used to fabricate iron and steel objects. The age of importing every last iron object ended around the time people were getting fed up with the high heels and lace collar crowd back in London. Yes, I mean the king and parliament. All these dudes were making laws while wearing high heels and lace. And wigs. Don't forget the wigs. But back to the metal. In the 18th century, there were two main types of iron being made from pig iron that had its slag pounded out. Cast iron, or iron that would be poured into shapes, and wrought iron, iron that was folded and stretched and then worked or wrought into shapes. Steels, that is, iron mixed with carbon and different amounts of other metals like chromium, nickel, manganese, and on, were all in development in this age as the chemical sciences were also being refined. Most objects during this period were cast iron. It was cheaper since it could be molded, and the objects were very durable, so it could be passed along in wills and survive a startling number of owners as long as the object didn't get rusty or face the sorts of use that would make it crack. Most cast iron has a higher carbon content, which makes it fairly brittle, but it can easily stand up to use as cooking tools and as interior door and building hardware. Items that would face weathering and needed to be able to bend and vibrate, stuff like ship fittings, wagon wheels, exterior door hardware, and possibly, most important of all, nails, those would all be made from wrought iron. Its higher slag or silica content that was worked in almost like a wood grain through long hammering and folding allowed it to resist rusting and be more flexible than cast iron. Nails of cast iron would have cracked under the pounding and wouldn't have been reusable and wouldn't have been able to stand up to the weathering or reuse nails were known for. A special class of cast iron was also used for making cannon. That iron had a unique set of challenges as it needed to be flexible enough to deal with repeated explosions, but not so flexible that the cannon would deform over time. It was a tricky balance to meet. An even well-made cannon that didn't rupture under fire would expand if fired too many times in a row. This, of course, meant that the lead shot wouldn't fit in correctly. Too much gas from the black powder explosions would escape around the sides of the cannonball or other projectiles, and they would not fly the expected distances. Oh, and then there would be the problem of carbon buildup inside the barrel from the explosions, and then there would be the problem... No, that's not what I'm doing here. The problems and mechanics of firing artillery in the days before self-contained shells. Again, another fascinating topic, but not what I'm here to talk about. What matters to us is that in the run-up to 1776, the colonies had furnaces for turning iron ore into pig iron, and then forges for pounding the slag out of the crude iron so it could be made into cast iron and wrought iron and cannon metal, and therefore make all the cooking tools, all the farming implements, the nails, the wagon wheels, the barrel hoops, the ship fittings, and so on, which meant they could function perfectly well if they were to be cut off from the iron and developing steel industries of England. And wow, here I am. I've gotten us all up to speed on what iron technology looked like at the start of the early war years of the country and how it got that way. So it looks like next week will be all about what it took to feed a forge, both the forge itself and the workers, and how these forges supplied the war efforts of this age and the home front. It is this period where lots of the guys who came to the colonies, or just straight up came to America, really started to spread their wings and working on innovation, or at least some of the Iron Masters did, and I'll talk about that as well. And you'll get some of the benefit of me getting to check out a Pennsylvania forge community from this very time period. And I'll also explain why Valley Forge, the one George Washington camped at for a couple of winters, was called that, and how the food economics for tens of thousands of soldiers and their attached campaign communities worked out. By the end, you will be so glad for hot water and soap. It will be amazing. Thanks for listening. Any questions or quibbles will reach me by email at thehistoryofamericanfood@gmail.com. I'll still be on Twitter as long as it's fun, but with this X announcement, I may call it quits. But I'm definitely on Threads and Instagram under the same name at THoAFood. You can also check out my new podcast, Prize-Fighters, Circus Freaks, and Gangsters, that's all about the 19th century mayhem, but this time with a co-host, Jamie Lewis. It's up on all your favorite podcast widgets. But unlike this one, it isn't E for everyone, just so you know. As always, a few words to review this podcast on your favorite podcast widget really do make a difference and help make me more visible to the food and history curious alike. Show notes for this episode will be at thehistoryofamericanfood.blogspot.com. Along with promised pictures and links, I'll also include any interesting media I consumed for the episode. Music for this podcast is Fingerlympics by Dr. Turtle. And all this information is also in the show description.